Good evening, everybody, and welcome to this evening's RENA London branch presentation. I'm Keith Lilly, the president of the RENA London branch. Today's presentation, as you can quite clearly see on the screen, is MARPOL and sewage considerations for livestock carriers. It's going to be given by Jonathan Morley of Lloyd's Register and Dr. Chen of Wartsila Water Systems Limited. A little bit about both our speakers. Firstly, Jonathan Morley. Jonathan graduated with a BSc Honours in Naval Architecture and Shipbuilding from the University of Newcastle. He then joined Lloyd's Register UK Graduate Training Scheme in 1981. He has gained experience of new construction and existing shipwork throughout the UK and has worked in both the pollution section and the chemical section of LR. He has obtained experience in a wide range of statutory aspects, and he is currently a lead specialist working on MARPOL chemical and gas codes. He also frequently attends IMO meetings related to pollution. Jonathan is a fellow of SNAMI, RENA, EMAREST, CILT, and CIWEM. Chen. Dr. Chen has extensive experience in environmental technologies and management systems across different industries. During his time in the marine industry, he has had executive managerial roles in R&D and engineering. In recent years, he has been focusing on regulations, policies, compliant design and operations, and advocating for evidence-based, practicable, and sustainable environmental rules. He is currently the Future Programme Development Manager at Wartsila Water Systems Limited. Jonathan and Wei will give their presentations and will respond to any questions at the end via the chat line. So if you want to populate the chat line with your questions, please feel free to do so. Please ensure your microphone is muted during the presentation. So without further ado, Jonathan Wei, we look forward to your presentation. The floor is yours.
Thank you much, Keith. The start of the presentation will be myself, and then Wei will do the second part. Thank you for attending this meeting. This is rather a specialist subject, but kind of has proved very interesting and a good discovery. So we're going to cover the cargo, the ships, the pollutants and MARPOL requirements, how sewage is dealt with at present. Can sewage be dealt with better? And there will be questions at the end, as Keith said. So the cargo. Well, kind of, there's a whole load of various animals. This is some samples of various kind of people, animals in their natural habitat. Has kind of got horses, donkeys, sheep, and cows, goats and pigs. So you get a good variety. And at one time, it was even more when this was the only way of transporting livestock around the world. This trade has had a big effect on the world. And how do we think, without long distance transport of animals, how do the sheep get from the United Kingdom to New Zealand? And how do the cattle and sheep get from the United Kingdom to Australia? How did the animals in the zoos get here from all around the world? And of course, that was by ships at the time. Not exactly the best type of kind of thing, but they were rather congested and kind of looked after as best they could. One of the big markets these days is the trade to the Middle East of various animals for consumption there. So the ships, we have a long history in this sector of the shipping industry, maybe longer than most. So if we can go from Noah's Ark, and you've got a giraffe on the bow of that one. So from that time to about the 1960s, trade continued by sailing, kind of sail ships or around the world. But in the 1960s, we had two developments which took place. One was the development of ro-ro ferries, so you didn't have to get the animals to walk on. They can stay on a road trailer and kind of be driven on to the ferry. And also aviation developed more when we had the kind of jet aircraft, where they could easily be put in the holds and looked after there. That leaves us mainly with the deep sea trades and some short sea trades. And that's a model of the Mayflower, to give that idea of getting to America. How do we get our livestock carriers? We have the various options. One is new build purpose designed vessels. An example can be seen on the Mighty Ships series, the MV Becru on Discovery or Smithsonian channels, which is regularly repeated on the television. The majority are conversions of existing ships, such as ro-ro cargo vessels and other ships such as tankers and or dry cargo ship. We have a more recent development kind of at the moment of live fish carriers, which support deep sea fish farms, but it could be suggested that it came under this category, but we're not actually going to cover the live fish carriers in this presentation. So a ro-ro ship, as you can see, you've got nice large doors. You have all the various ramps, so the animals can go up to the various decks quite easily. You don't have to add too much more accommodation at the top. The problem will be also the storage of the fodder and the food, and also if you have any storage or any other things that you need for the animals, such as fresh water, a tank to put the fresh water in. So you're going to have to go through bits of the car deck unless there's enough volume under the waterline. If you go for a dry cargo ship or a tanker, you've got the holds, so you've got the hatch covers. You can put the food and use it for fresh water, or some of the tanks for fresh water if it's top sides on a bulk carrier. The same on a oil tanker. You can take some of the decking out and have access to what were the old cargo holds. So you can just build up above the main cargo area. Again, you may have visibility problems. Sometimes they put a kind of a wheelhouse at the front of the accommodation, and the same on the tanker. So if we look at the pollutants and MARPOL requirements, the main bits from the cargo is livestock sewage, and of course that will have straw because they're in various pens. In the definition of sewage, in regulation 1.3.3, it says includes the drainage from spaces containing live animals. And also every ship is required to have one of the following: an approved sewage treatment plant, or a sewage commuting and disinfecting system, or a holding tank. And regulation 10 requires you to have a standard discharge connection. Regulation 9 and 10 apply to all ships. It's not just the livestock carriers. We do have dead livestock, fortunately, and there are recommendations in the Polar Code which recommend to minimize the risks associated with cargo mortalities and should be given how animal carcasses will be dealt with, treated and stored on board. So you may need certain spaces to actually store them, and especially if you're in the polar regions, it will be rather cold. There is also a MEPC circular which has the segregation of spoilt cargoes, which actually shows the split between MARPOL Annex 5, which is ship's wastes, and the London Dumping Convention. The other pollutant is air pollutants under MARPOL Annex 6. There's methane from animals' digestive system, which gets quite a lot of publicity in the general press. And the other is ammonia vaporization, which is from livestock urine. Those both are at present not regulated. So from the cargo, the main discharge of sewage with straw, as you can see, there's an example there. For the discharge, the sewage has got to be applied with the following requirements: from the nearest land or any ice shelf or fast ice, and shall be as far as practical from areas of ice concentration exceeding 1/10. If you've got if you're discharging from comminuted and disinfection sewage system in accordance with regulation 11.1.1, you've got to discharge more than 3 nautical miles. If you're discharging from basically raw sewage, you've got to be at least 12 nautical miles and at a moderate rate. If you have a sewage treatment system approved to the IMO requirements, you've got shall be as far as practical from the various ice and other from the land, but you can discharge anywhere. We come on to national requirements. Australia has a vast experience in the carriage of livestock. It has been a major export over the years. They've got a Marine Order 43 for cargo and cargo handling livestock, 2018. This covers the welfare, pollution, stability and fire requirements. In paragraph 6 for the application, it applies to Australian vessels and also foreign vessel at a port in Australia. In Schedule 2, Part 4, there is drainage of pens, which will include some cross-reference to MARPOL Annex 4 and MARPOL Annex 4 requirements. In the part of that section, there is paragraph 4.8, which any equipment on the vessel that is installed to comply with MARPOL Annex 4 must be operable in both primary and secondary sources of power. Which is rather surprising that the Australian animals or livestock are actually more explicitly covered than the safe return to port requirements for passenger ships. For each ship, they have a record of equipment, and also when the Australian government is fully satisfied, they'll have an Australian certificate for the carriage of livestock, which they will attach a copy of the record. Also, if you are intending to load livestock in Australia, there is a form for notice of intention to load them, and you're signed by the shippers and will be signed off by the Australian AMSA, which is the Australian Flag Authorities, if they agree with it. This is a extract of part of the records which I just referred to, which, as you can see, deals with the drainage from the areas where the animals are, and also a sewage retention facilities. And then there is also a section here which has the arrangements under Annex 4 for the discharge of the livestock effluent. So it is specifically just for how you are dealing with the livestock. And it is suggesting there kind of sewage treatment plant, holding tanks, and also the maximum rates of untreated sewage that you have. There are two other marine orders. One is Marine Order 96, which basically does MARPOL Annex 4. And then there's a general legislation Act of Parliament, which is actually the MARPOL requirements. The other area that has kind of requirements is the European Union. There is Regulation EC number 1/2005 for the protection of animals during transport and related operations. This is only on animal welfare. There has been a kind of European parliamentary study which on animal welfare on seas and criteria for approval of livestock authorization. There was a workshop on animal welfare during transport on the 25th of May 2021, so very recently. This is available on the internet. At this study, they also looked into the pollution aspects and also looked into the Australian practice, including Marine Order 43, which we heard earlier. So I'll pass over to Wei for the second part of the presentation.
Thank you, Jonathan, and thank you, Keith, for holding the event. Hello, everyone who are listening. Yes, I'll continue with the subject. For those who don't know, Wartsila is the company I work for, is the world leading marine equipment supplier, and part of our company do deal with animal carriers. And we have a Wartsila Voyage division who do the planning, ship planning, which would improve the animal welfares and things like so. But of course, also part of our business focus on the environmental aspect of the ships as well. Sewage is one of them. So to continue the theme, a recap of the regulation itself. Regulation 11 is about discharge, sewage discharge. And then, of course, it's mentioned sewage holding tank and the rest of it. But if you take a note of the second line of that paragraph, it says sewage originating from space containing living animals. So this is important. This basically is to say this space is in parallel of the holding tank, as I mentioned in the first slide. So the two things can be allowed to discharge into the sea at a moderate rate. So there's two things, holding tank and the space. And then the moderate rate itself, if you look at the small wording at the bottom of the first, is according to this resolution MEPC 15755, where the rate is defined. There's a formula. But it does mean that this space, because it can discharge directly overboard, actually, when you're thinking about it, it's difficult to apply this rate to the sewage coming off the space directly into the sea. So there's a little bit of a inconsistency in there to note. And for this slide, you were able to see the comparison between sewage discharged from a cattle to the human, and the two set of numbers to note. First is the circled BUD. BUD is the amount of organics in the waste. So one cattle equivalent to, say, 10 persons, right? 550, 10 persons. The other number to note is to the left, where you can see 1 after human. So human, on average, discharge 1 kilogram per head per day. Give a density of 1, it's like 1 liter per person per day. So this referring to undiluted sewage. So this is the basis of this moderate discharge rate. It's based on undiluted sewage. 1 liter per head per day is much lower than what we typically know as for the human ships, let's call it, the vacuum systems, where the numbers will be from 15 to 25 liter per person per day. For a cruise ship, if you include gray water in there as well, it will be 250 liter per person per day, much higher than 1, which is the undiluted sewage from a human. So just a few numbers to note. And then if we take that, a carrier carrying 20,000 cattle will be equivalent to a 200,000 people city. So that's how equivalent in terms of the sewage loading in from the ship. And when you compare the hydraulic, i.e. the volume of it, and then a 20,000 cattle carrier, something like 400 ton a day. Well, whereas a 200,000 people city is more like 40,000 meter cube per day. So in terms of volume, is very different as well. So next slide, please. So here is interesting. I bring you to this guideline about the formula of the moderate rate. I circled 2 things there. One is basically after the study, I think it was proposed by Australia many years ago, it worked out that if you discharge 1 portion into 200,000 portion of the sweat volume, I show it kind of in the diagram. You can see there's a shape after the ship. So the faster the ship goes, the longer this volume is going to be, but it will be like that. That is what visually as a sweat volume. So that 1, circled 1, referring to undiluted sewage, right? 1. And the second thing I circle in there is that this formula, as you can see there, is based on average discharge rate as meter cube per hour. And what it means is that they work it out based on the 20,000 cattle ship, the volume discharged, and they worked out the sweat volume. And then every hour you can discharge, for example, 400 ton of it. It cannot be more than that. It's not 400 per day, so you've got to divide that by 24. So you can only allow to discharge that much volume per hour into the sweat volume. If you discharge more than that, you're over that requirement. So here's one thing to note. Because it's based on the average, so that only happens if this animal carrier is washed down continuously every hour, 24/7, and then you get that average rate. But if you only wash down half of the days during the journey, during the itinerary, and on those days you're doing the washing down, you only wash 3 hours a day, or 8 hours a day, or a third of the day, it's during the day, for example, then actually the average rate as a result of it is 6 times of what this formula is saying, because it's not spreading out 24/7. So that's something to note as well. The third circle in there is to say this formula actually do not relate to the number of person or animals on the ship, because those to do with speed, the draft, and the breadth of the ship. So then if you look down, I listed down there, is as a result, a 20 crew bulker and the 2,000 person cruise ship and the 20,000 cattle carrier, which is equivalent to 200,000 people, they actually ended up with the same moderate discharge rate. So, just put things into perspective. And this one is very simple. It's just to say, if we were to build a sewage treatment plant for 200,000 people, it will be something look like this. I actually took it from Google, just to give you a visual impression. And on the right-hand side, I list down some numbers in terms of the treatment facilities you would need it. And there's so many zeros in there, you can quickly tell it's not possible to do something like that on the ship. So the next slides, please. And then if you were to do something on the specifically for the cattle carrier, because actually the volume is less, because it's not like in the city. We only got 400 ton, not 40,000 ton, the hydraulic load. If you were to do something similar, like anaerobic digestion or things like that, and then you will still end up quite a lot of reactor volumes needed, and for arriving at a discharge which compliant to the MARPOL Annex 4 requirement. So the feasibility, we can look into it, but is a very tall call just from the outset. So next slides, please. And now to summarize the current situation. So we can say that animal carriers or livestock carriers, they are by far the biggest sewage discharge within the shipping industry. The other ones, even cruise ship, you cannot compare. But then, as we know, some of us know, we have the first special area under MARPOL Annex 4 now, which is the Baltic Sea. Actually, because a cattle is not a passenger, so livestock carrier actually is not categorized as a passenger ship, so it's not subject to the restriction that brought to the special area. So I thought, okay, that is also a little bit of an oddball, because we're trying to address the nutrient issue, and you target the passenger ships, but hey, here is a big source. Okay, give that maybe there are not many livestock carriers in the Baltic Sea, but if you ever have one, it's big. And the next one is the washdown, as we said, is only doing, in reality, is only done on some days, some hours, not continuous. So then you apply the rate to that ship, there's some discrepancy there. The overall, the overboard discharge from the space containing the animals can directly go overboard without having to go into a holding tank in the first place. So there's a little bit of discrepancy there. To have a sewage treatment plant on the ship, I just say is challenging, as you can see some of the numbers and pictures earlier. And another option under MARPOL 4, as Jonathan mentioned earlier, is the CDS. We call it comminuting and disinfecting system. But this unit, by the looks of it, needs a lot of chemical, and it may on its way out because it had its own environmental impact by using a lot of chlorine. So next slide, please. And what can be done better? So now we all see the challenge. It's not easy, but there are things can still be done, I believe. First of all, collection. We have to collect the sewage. This space, from the space goes directly overboard. If we continue with that, then there's no starting point. So we have to stop that and start to collect it into a holding tank. That's a prerequisite. And secondly, once it's stored, we can do more things about it. For example, in the special area, we can hold it in the Red Sea and some other places where you go, the people concerned is close to shore. at least you can hold it for a little period while still can do the wash down. At the moment, people have to stop the wash down, so that will affect the animal welfare. So by holding it, you are allowed to do the cleaning, you keep the animal happy, but then you hold it. So then, of course, that will also need a review of the moderate discharge afterwards to allow that to be discharged. But by the time you hold it, you need to look after the condition, how this sewage is held in the tank to health and safety risks and all the rest of it. And then when it comes to discharge, we need to review how that can be discharged. And then, of course, another thing can come into play is port reception facilities, because there's a big push in some of the regions to say, hey, give us in the port, we will take it, we'll look after it for you. So in some places, we also can see this animal waste. It can be perceived as a fertilizer, as a valuable natural resource. And that's how municipal sewage sludge has been dealt with. For example, in UK, it's used for agriculture. So port can play a role. And sewage record book has already been discussed under the revision of MARPOL 4 right now, and that could play a role as well. So that's one of the things. This slide, I think, is quite important. Is to say, in addition to holding it and manage it on ship and in port, and there's one thing important. We took a paragraph from an EU report, which emphasized in the small wording, page 45, it emphasized the biohazard of the animal sewage because they carry a lot of pathogens and different bugs, which can pose a risk to things like oysters, shellfish, other shellfish. I don't know, some of you may know in Washington state of the United States, outside Seattle, this big water area called Puget Sound. And they actually imposed a sewage discharge ban to all ships, purely because, as you know, over there is a lot of shellfish bad for oysters and all the rest of it. So they banned sewage. So this biohazard is one of the major concerns for sewage, not only animal sewage, but just untreated sewage in general. But then one thing could feasibly done, I believe, is called pasteurization. It's a process using temperature and time relationship. You basically cook it to it, and then you kill the living thing in there, and then you discharge it. Then at least it doesn't remove the beauty or the organic load, but at least it can effectively address the biohazard. And this is a process for land-based sewage sludge as well. Before it goes to agricultural land, sometimes you use this process to do something. So I think, and this sometimes, for example, 70 degree, 30 minutes. So it's not something that will shock the marine architect or engineers, because in the old days, the heavy fuel tank, and 70 degree is not something that will shock us. And 30 minutes is not something that will shock us either, because it wouldn't end up a huge volume to do that. And when we're talking about ballast water, there are also people talking about pasteurization. They're talking about even 50 seconds. So that's a separate subject, but it's something that is not unfeasible to do. And come to the last slide here, the implication to other ships. Now, early on, we mentioned cruise ships. I circled one number for a 5,000 people cruise ships. We're not talking for undiluted sewage. So it's not like 1,000 ton or 100 ton even from a cruise ship. We're talking about 5 ton because it's based on undiluted sewage. So how that transpired to the moderate rate that we currently apply to cruise ships and all the other ships as well, that need a little bit looking at, because I believe in many cases, the moderate rate has been applied to what I would call diluted sewage, because human ship, we do have a button to press, whether it's gravity or vacuum toilet system. And by the time you press that button, it goes down, a lot of water would goes into to dilute, more than so on animal carrier. So there's something we need to pay some attention. So then it comes to the last slide. Jonathan, do you want to do it, or do you want me to do it?
You do it if you want.
Okay, so actually, Jonathan has listed a few bullet points just to summarize the consideration here. The first one is to note the difference between the sewage from crew working on the animal carriers and those from the livestock themselves, because you end up two different systems. When we do the conversion, for example, if you do a car carrier, there is already a sewage treatment plant built there for the car carrier, but that's only for the crew, not for the after the conversion for the. So something to note. The second bullet point is about the space, the drainage from that space, from the animal pens. How do we better reflect that under the regulation? And the last point is about the certificate itself, how to reflect the two different systems. So that kind of capture some of the considerations, and that concludes our presentation.